So thank you everyone for taking the time to join this session today. As we just discussed, I hear that there's people all over the world tuning in right now. So I just wanted to say good morning, good afternoon, good evening. I hope everyone's doing well right now, regardless of what time zone you're in. So my name is Emily, and I am a PM on the Azure Data team at Microsoft. And so what I focus on is high availability for Azure SQL, which is what I'll be discussing today, are high availability options that exist for Azure SQL. So right now, I am talking to all of you in my living room in Seattle, Washington, that my roommates graciously let me use for this presentation. So thank you to them for letting me use this. I'm sure many of you have had similar experiences as what I've had recently since this pandemic hit, where you suddenly and unexpectedly had to change so many things in your life. And so this spans from having to work from home, having to do these virtual conferences, really all aspects of life had to be adapted in order to adjust for this unexpected change. And so through this experience, one thing I've realized is how important it is to recognize that nothing is perfect. Unexpected things happen, and it's crucial to be ready to adapt to unexpected changes in order to stay, in a sense, available. Similar to how unexpected things happen in the world around us and how we had to quickly adjust, databases are also not immune to these abrupt changes. At any moment, a natural disaster can take out an entire data center. A network failure can impact the functionality of a few servers, and many other unexpected events can occur, potentially jeopardizing the availability of your data. We embrace this reality by actively working to minimize the effects of a single failing component with as little downtime as possible. So today, I'll be talking about how we can embrace the unpredictable world around us by using systems that actively account for mistakes to be made and for things to break. So the agenda for what I'm going to go over today, I'm going to start off by level setting some high availability concepts. And then next, I'm going to go through a brief overview of the history of high availability through SQL Server and how it's evolved over time. Next, I'm going to focus on high availability that exists within the cloud for Azure SQL, and then focusing on the zone redundant configuration, which is what I believe is the future of high availability. And then finally, summarize what we learned throughout this entire presentation. So to start off, let's get on the same page about some general high availability concepts. So one term I hear thrown out a lot in the business continuity space is something called HADR, which stands for High Availability and Disaster Recovery. While high availability and disaster recovery are similar concepts, they actually target different scenarios. So the goal of high availability is to have continuous availability of the database with resilience to local failures. This covers recovery from local failure and software failures in an automated way that is transparent to the applications that use the database. Now, on the other hand, the goal of disaster recovery is to quickly recover the database from a failure to provide business continuity and protect the business by minimizing any potential data loss that might happen. So next, the span of time for high availability for failovers is in the span of milliseconds to sub-millisecond time. So the idea behind this is that there should be no disruption to the user and happen very fast. And this is because the scope of high availability is hardware and software failures within a region, so within a closer area, whereas on the other hand, disaster recovery has a longer time to fail over because the scope can be across regions for much larger scale disruptions. And so for high availability, the type of replication that is typically seen is synchronous replication. And what this essentially means is that your primary data source waits on making any more changes until the majority of your secondary copies respond acknowledging that it has received the update from the primary. And now what this synchronous replication does is this helps prevent data loss since there's no lag between when the transaction is committed to your primary and when it's replicated to your secondary copied data sources, which allows for this synchronous copying to exist elsewhere. Whereas in disaster recovery, what you typically see is asynchronous replication being used, which asynchronous replication what this does is you don't wait for that acknowledgement from the secondaries for the primary to make future changes. And this works well for longer distance synchronization where you don't really want to have that wait time across the globe to hear back from a secondary to have future changes made. And now, so how these are measured is also different. So for high availability, that is typically measured in percentage of uptime for a service, which is a concept I'm going to describe more in the next slide. Whereas disaster recovery is measured by RPO and RTO, where RPO stands for Recovery Point Objective, which is essentially the amount of data loss that can occur from an outage, whereas RTO, Recovery Time Objective, is the amount of time it takes for your database to restart after there is some kind of failure. So going more into what the uptime percentage means corresponding to the metric for high availability, a term that gets thrown around a lot in the high availability sphere is the terms of nines. And so a lot of times what you'll hear is, how many nines of availability does your database offer? So I want to go through and demystify the concept of nines. So these nines are based on an SLA, which is your service level agreement. So this is the agreement that a customer has with your company regarding your resources. And what this essentially means is that a company will say, we guarantee this standard, and if we don't meet it, you get some level of money back. And so specifically in an SLA for the nines, this is measured in availability as percentage of uptime. And the way that uptime is defined varies company to company, so that's something to pay attention with each company's specific SLA. At Microsoft, for Azure SQL, the way we measure uptime is by how we define when a database doesn't experience downtime. And how we define downtime is when all continuous attempts by a customer to establish a connection to the database within the minute fail. This is a pretty standard definition that exists for uptime. However, some places have different definitions, which can range from things such as your region being in a state of region unavailable, to things also such as having a large percentage of server-side errors in a given time. Now, looking at these nines and what they actually represent in terms of acceptable maximum amount of downtime, here's a table that gives some common availability percentages and the corresponding downtimes. So starting at the top, when you hear the term 1.9, that refers to literally just 1.9 in the availability percentage, or 90% availability. So what this equates to in actual time per month, that's 4,380 minutes of downtime per month. Now, going down to 2 nines, or 99%, this downtime decreases all the way to 438 minutes per month. Going to 3 nines, you see for 99.9%, 43.8 minutes per month as the maximum downtime. And then 4 nines, 99.99%, it goes all the way down to just 4.38 minutes per month of maximum downtime. And so one thing you might be noticing looking at this slide is I'm talking a lot about nines, but there's also 5s on this slide. So there are also 5s, for example, this 99.995% availability. And you might be thinking, what would 0.005% add as additional availability to the database? Well, actually, there's a pretty big difference between 99.99% and 99.995%. And if you look at the corresponding downtime, there's actually a 50% reduction in the maximum downtime allowed by just adding that 0.005%. So even that additional 5 gives a pretty large improvement to the amount of availability for your database. So now that we've gone over some level setting of high availability concepts, I want to do a brief walkthrough of the history of high availability, specifically from SQL Server over time. So as a starting point, in 1989, this is when the first edition of SQL Server was released. Now, while SQL Server has always had ACID properties for recovery, the initial storage and compute resiliency that existed was pretty minimal. All of the, in a sense, high availability, or HA, that existed in these initial editions of SQL Server was based around local database and transaction log backups that were applied to the same server. These backups are also typically not taken very frequently. A lot of logs were typically backed up about once a day. So on top of that, the hard drives and hardware that were used back in the day are not as sophisticated as the hardware you see today. So they were more error prone and more prone to failures. And while this was the very beginning of SQL Server and databases, some customers still wanted to build systems to have replication and have some level of high availability. So what some customers would do is build their own automated systems of standing up another server and continuously restoring backups on this. Now, since customers implemented this on their own, this was typically very complex to implement and involved a lot of manual work to figure out how best to monitor this health of your database and how to adjust when hardware fails. And since this was pretty complex, difficult to set up, and error prone, most customers just depended on the local backups as their full high availability solution at the time. Next, after a few additions of SQL Server in SQL Server 6 in 1995, this is when replication was first introduced for SQL Server. And what this means is this was the first time that we provided the ability to set up another server and send data from your primary database to a different server. And this was often used to have some read workloads offloaded to this other server, but it also could be used as a starting point for high availability. However, this did require manual failover, and it also required the customer to reconfigure their app and client configurations to connect to this other server, which is a pretty complicated and time-consuming process since they would have to reconfigure all of these connections. Because of this, people often continued to simply restore backups on the same server in similar ways that they did for previous SQL Server editions. Now, the two forms of replication that were introduced in 1995 were transactional replication and snapshot replication. And high level, what these are, so transactional replication, this is when your publisher will send transactions one at a time as they come through to your publisher to the corresponding subscribers or like copies of your database. And what this is good for is a high volume of insert, update, and delete activity when you need speedy updates and to keep track of incremental changes rather than a net change that would exist to a database. And then on the flip side, the net change is handled by snapshot replication, where your data is distributed exactly how it appears at a given moment from your publishers to your subscriber. And what this is good for is infrequent data changes when it's acceptable to have out-of-date copies and replicate smaller volumes of data. So that's high level, these two replication systems that were introduced in SQL Server 6. Next, in SQL Server 7, which was first introduced in 1998, we have the concept of a failover cluster. Now, what failover clusters did is they leverage Windows failover clustering technology to provide a local high availability solution at the server instance level through failover from one node to another if your current node becomes unavailable. Now, this failover cluster technology was a game changer for two main reasons. The first is this provided an automated way to detect a failover problem. And then the second is this solved the issue that I've been discussing where customers previously, if they wanted to use a different server instead, they would have to reconfigure their application and client connections to instead route to this replica. These failover clusters, they provided a virtualization of node connections with virtual network names, which allowed for a simple redirection to this other node without manually having to reconfigure the application and client connection information. While this provided a lot of benefit in terms of having this virtualization and automated failover, there was one major drawback of failover clusters, and that is that the two nodes had this shared disk array. So since the nodes would share storage, storage was a single point of failure. So really, failover clusters more targeted the hardware that's running SQL Server processes rather than the actual storage for data loss, for potential data loss. Another thing that was introduced in SQL Server 7 is the concept of log shipping. I don't want to discuss log shipping too much today, since this is a bit more of a disaster recovery solution than a high availability solution, and I'm focusing the session on high availability. However, I do think it's interesting to note that what log shipping did is allowed you to automatically send transaction log backups from your primary to secondaries on a separate secondary server. And so essentially what this did is automated the process that was discussed starting in 1989, where customers were standing up a server and continuously restoring backups to that different server. So that process customers were trying to implement their own. We automated this and provided it through SQL Server. Next, in 2000, with SQL Server 2000, merge replication was introduced. I'm not going to get too much into the details of how merge replication works, but it is important to note that we did have this third type of replication introduced. And what merge replication essentially did was allow various sites to work and make changes autonomously and later merge these updates into a single uniform result by using this merge agent here. So both the publisher and subscribers could make changes that would later be merged and sent everywhere. Then, in 2005, the concept of mirroring was first introduced. And the way mirroring works is that you have your principal database, and all transactions that are made to your principal database are then mirrored to a mirrored database with an optional witness server acting as an intermediary to determine when a failover should happen from your primary database to your mirrored database. This automated failover solution was similar to the failover cluster solution that we discussed that was introduced in 1988, but we no longer have this shared storage as a single point of failure. A few things to note: that even though we no longer have that, we do only have one replica that can be mirrored to with database mirroring, and failovers are based on server health rather than the health of your database. So your database could potentially have issues, but if the server isn't detected as unhealthy, you might not fail over. Now, another game changer for high availability was also introduced in 2005 called fast recovery. And so what this is for SQL Server, whenever a database recovery needs to happen, it goes through a three-phase process of analysis, redo, and undo. And so what happens in the analysis phase is that the state of each transaction that occurred since the last successful checkpoint is analyzed. And then it goes into the redo phase, where data is brought to the state before the crash by redoing all committed operations. Then it goes through the undo phase by rolling back and undoing any operations that were performed by transactions that were active during the time of a crash that would require this recovery to occur. So this whole recovery process used to take longer time, and your database wouldn't be available while it was going through recovery, until fast recovery then made the database available at a sooner point. So previously you had to wait for all three phases to complete, which undo especially was typically the longest one to complete. However, in 2005, we made it so when the redo phase was done, that's when your database became accessible again. And this was done by maintaining locks during the undo phase to avoid any potential inconsistency issues. So now, through this fast recovery, the database became available much sooner in the recovery process. So then we're going to jump ahead a few additions to SQL Server 2012, which is when always-on availability groups were first introduced. So always-on availability groups, they are based on mirroring, was the predecessor, which we talked about in 2005, to these always-on availability groups. And these always-on availability groups are the availability solution that we see today for SQL Server. And this leverages the Windows failover clustering technology. Now, for always-on availability groups, rather than having the one replica offered by the previously discussed mirroring solution, we now support for multiple replicas and support both synchronous and asynchronous replication. And what this also provided was a way to group together multiple databases to act as a single unit of failover. So this further expanded the virtualization piece through connecting to these replicas with the concept of an always-on listener that accepts centralized requests for these high availability groups through having a unique IP and virtual network name. The secondaries that exist in an always-on availability group, which can exist locally or in different data centers through synchronous and asynchronous replication, they can also be configured to handle read-only workloads. So these secondaries both have that high availability value and also that read workload offloading value as well. Now, since these always-on availability groups are what we use today, we didn't just stop there in 2012. We continued to enhance always-on availability groups over time. In 2016, we saw several key enhancements to always-on availability groups. So starting with failovers, starting in 2016, were now based on the health of the database rather than the health of a server. So unhealthy databases, you'll have that automated failover to a new server to run the SQL Server process. There also were several performance improvements made, causing the availability of groups to be turbocharged to be much faster. And there's also a feature introduced for always-on availability groups in 2016 called distributed availability groups. And what this essentially did is allowed availability groups to be chained together regardless if they were in the same Windows Server failover cluster or not. Furthermore, another enhancement that was made in 2016 is that it went from having 5 replicas being able to be supported for a database to 8. So you could have even more replicas supported for an always-on availability group. Then the most recent edition of SQL Server, SQL Server 2019, one key advancement for high availability that was made in the most recent edition is something called accelerated database recovery. So what we saw with fast recovery, which was previously discussed in 2005 with having the recovery process speed up, well, this recovery process got even faster in 2019. And this was done by redesigning the engine recovery process so that the recovery time was not impacted by long-running transactions. What was done is that optimizations were made so that recovery time is now constant time rather than dependent on the number and size of active transactions in the system. There's also more replicas, even more replicas added in 2019 for always-on availability groups. So that was a high-level overview of how high availability has improved over the years since 1989 for SQL Server. Let's look at how these high availability enhancements are also used for Azure SQL in the cloud. So to start off, let's go over what even is Azure SQL. So we have multiple offerings that fall under the Azure SQL umbrella, all of which are built on the same SQL Server engine that was discussed in the SQL Server architecture. So we have IaaS offerings in the form of SQL Server on Azure virtual machines. So what IaaS, or Infrastructure as a Service, is that the customer, you manage the stack up to and including the operating system, and then we manage the rest. This solution is best for customers who require ultimate control over SQL and the operating system, which is typically useful for customers who use features that require this operating system level of control, such as Polybase, file stream, or if you want to have like a third-party software installed side by side of your SQL Server process. This has 100% code compatibility with SQL Server, which gives you access to the latest SQL Server updates and releases. Now we also, other than just IaaS, we have PaaS offerings, or Platform as a Service, which what this means is that as a customer, you manage the stack up to, but not including the operating system, and we manage the rest of the stack starting at the operating system. So one of our PaaS offerings, called Azure SQL Managed Instance, has nearly 100% compatibility with your on-prem SQL Server, and also allows for control of network traffic between app and data tier with native VNet support. And this solution is really good for those who want to modernize their existing apps that already run on-prem SQL Server. In addition to Managed Instance, we have Azure SQL Database, which is our other PaaS offering. And Azure SQL Database is best for customers who are building new apps in the cloud, and they want to leverage all the cloud's capabilities of fast provisioning and scalability. Specific to Azure SQL, we have several different options for different kinds of applications. On the compute side, we offer both serverless and provision compute. In terms of performance tiers, we have different performance tiers that target different kinds of applications, one of which is the hyperscale performance tier, which allows for highly scalable storage and compute. In today's presentation, I'm going to focus on the non-hyperscale service tiers, and this decision was only made to scope down the session to fit within an hour. However, the hyperscale tier also has all of the high availability goodness that exists in the cloud with built-in replication across all of its layers. If you would like to learn more about what the high availability architecture looks specific to hyperscale, please feel free to visit our public documentation on high availability, where we provide that information. I provide a link to this document at the end of these slides if you would like to look at that after the session for reference. So now that we've gone over what Azure SQL is, what high availability is offered by using Azure SQL and using your database in the cloud. So first, for all of Azure SQL, we have built-in maintenance. So virtually all infrastructure maintenance with Azure SQL Database is automatically handled as part of the service. This spans across patching, backups, Windows and SQL upgrades, as well as unplanned events such as underlying hardware, software, or network failures. So what this does is this allows customers to get the full benefit of replicated database without having to configure or maintain the complicated hardware, software, operating system, or virtualization environments. Another key benefit to having your database in the cloud in terms of high availability is that fault tolerance is built into each Azure SQL database with replicas using the quorum writes technique to automatically deliver inherent data protection, database uptime, and system stability. These system replicas are also automatically moved to new machines, provisioned anytime, anywhere, as an old machine may fail. And this is done using the Service Fabric failover system for failovers that are fully automated without loss of committed data. The routing of connections from the primary to these new servers is also done automatically with no changes to the application. Now, looking back at the history of SQL Server, let's add in the pieces for when Azure SQL came into the picture. So starting in 2010, this is when the first version of Azure SQL was publicly released. The way that Azure SQL first handled high availability, we had our own internal, in a sense, replica system that ensured that we always kept 3 replicas available. Through this, we automated processes like backups and kept multiple copies of your data. Then, in 2014, all of Azure SQL was re-architected and improved to become more efficient. This Azure SQL was run on the same engine as on-prem, so we can fully use all of the greatness that was developed over time for SQL Server in terms of high availability that could be used in the cloud as well. And the way that this re-architected Azure SQL was presented to customers was in the form of DTU service tiers, where a DTU service tier is essentially a prepackaged bundle of a certain amount of storage and compute that a customer selects for what they want for their database. And the different tiers have different high availability replication architectures. So starting with the standard tier, this tier is designed to meet the needs of most workloads. And the availability model, how this works is by utilizing a separation of compute and storage. So for the storage part of the database, this uses Azure Premium Storage, which is locally redundant, which means that this data is replicated locally 3 times within the same region. This redundancy guarantees that data will be preserved even if the SQL Server process crashes. Next, backups are also stored in Azure Storage remotely, but instead of locally redundant storage, this is globally redundant storage. Essentially, what this means is that these backups not only are synchronously copied 3 times in your primary region, they're also copied additionally asynchronously to a second region as well, having that very high sense of fault tolerance and safety for these backup files. Now the compute aspect, which is separated from the remote storage for the standard tier, is operated by Azure Service Fabric that initializes the SQL Server process, controls the health of the node, and performs failover to a node of spare capacity in the case where a failover is needed in terms of some kind of crash happening. The data that is stored in Azure Blob Storage is not affected by any move that would happen from your primary replica to a node of spare capacity. It's simply attached, the compute is simply just reattached to this storage after this failover happens. And with any failover, we always use accelerated database recovery that was introduced in 2019 in the cloud to make sure that this recovery happens as fast as possible. Now, one thing you should be thinking is that this architecture for the standard tier looks pretty similar to something that we've already discussed, which is these failover clusters that were introduced in 1998 to SQL Server. However, one thing to note is that while the failover clusters had this single point of failure in having shared storage, this is not a concern for Azure SQL because Azure Storage provides this redundancy and resiliency through locally redundant storage in Azure Storage. So the next tier that I'm going to talk about is the premium tier and how this is designed. So the premium tier is designed for mission critical applications that would require a higher level of performance and higher transaction rates to have minimal performance impacts to your workload during any kind of maintenance activity. So this architecture is a bit different than the standard tier that was just discussed because instead of having your compute and your storage separated with remote storage, you actually integrate your compute resources with locally attached SSD storage on the same node. And through the premium tier, high availability is achieved with always-on replication, similar to what we saw introduced in 2012 with always-on availability groups. And this is done by synchronously replicating this compute and storage in a 4-node cluster. So what happens is your primary replica accepts read and write workloads, which are constantly pushing changes to the 3 other secondaries for your database, guaranteeing quorum before committing each of these transactions. And so what this guarantees is that if your primary crashes for any reason, there's always a fully synchronized node readily available to fail over to. The way backups are handled for this premium tier is in the same way as in the standard tier, where there's that global redundancy managed by Azure Storage that exists for backups. One additional benefit to note specific to this premium tier is that one of these secondaries can be used to offload read workloads for something called read scale out, and this is offered at no additional cost on top of the normal cost for the premium tier. So in 2016, we had all of this engine improvements, but we also have, and redesign, but we also had geo-replication, where geo-replication is asynchronous replication of the full database. So that is your database, including all those replicas that we talked about, to an entirely different Azure region. So what this allows for is a quick disaster recovery solution of your individual database in the case of an entire regional disaster, really accounting for the very large scale outages. With geo-replication, you can have up to 4 readable secondaries. And this provides a business continuity solution at a global scale that is very simple for customers to use. Now, the next main year I want to call out for Azure SQL for high availability is 2018. This is when we introduced the concept of the vCore purchasing model, which you see today. And what the vCore is and how it differs from the DTU model that I talked about in 2014 is for vCore, this allows you to independently choose compute and storage resources for your database. Now, the architecture for vCore is very similar to what I just discussed for DTU, where your general purpose tier has the same availability architecture as standard in DTU, and the business critical vCore tier has the same availability architecture as the premium DTU tier that I just discussed. Another enhancement in 2018 is the concept of an auto failover group. And what an auto failover group is this is a level of abstraction on top of the geo-replication that I talked about that was introduced in 2014. Where what this does is this simplifies deployment and management of geo-replicated databases at scale. And this follows similar technology to what was discussed in 2016 with having the distributed failover groups in SQL Server 2016. Last, the other big high availability improvement that happened in 2018 is the concept of a zone redundant configuration. Now, this is what I view to be the future of high availability in the cloud, and is something that I want to dive more into next. So what the zone redundant configuration uses is a concept of availability zones. Now, let's go over what is an availability zone. And I think it's important to understand what an availability zone is to first understand what's an Azure region. So the definition of an Azure region is a set of data centers deployed with a latency-defined perimeter and connected through a dedicated regional low-latency network. Availability zones are unique and physically separated physical locations within an Azure region. In order to ensure this resiliency within an Azure region, there's at minimum 3 separate zones in each AZ, which stands for Availability Zone, enabled region. Each of these AZs is made up of 1 or more data centers equipped with independent power, cooling, and networking. And since each of these zones has these independent power, cooling, and networking, what this means is if one zone goes down, the other zones in the region won't be impacted. So how this is really utilized to its full potential in Azure is through zone redundant configurations, which is when the Azure platform automatically replicates your service across these availability zones within a region to protect from single points of failure, since, as we discussed, one zone failing should not impact the availability of another zone. For Azure SQL, we currently offer zone redundant configuration for the business critical and premium tiers, which I'm going to go into the architecture of that now. So the zone redundant configuration we offer for Azure SQL is within these business critical and premium tiers. And as you see in this architecture diagram right here, this architecture looks very similar to the replication architecture I just discussed for the premium service tier. Except the one difference is that these 4 replicas that come with every premium or business critical Azure SQL database, they're automatically created in the 3 different availability zones. So by spreading out your replicas to the different availability zones, you make your database resilient to a much larger set of failures, including catastrophic data center outages without any changes to your application logic. So if one availability zone goes down, you have your replicas in additional zones as well. This uses synchronous replication, so we still maintain the near zero data loss and near instantaneous failover. And all of this additional high availability benefit to a much larger set of failures is added at no additional cost to the customer and is easy to configure without changes to application logic. So I'm going to do a quick demo just to show how easy this is to implement for your business critical and premium databases. So this can be done in CLI and PowerShell and ARM, but I'm just going to show how this is done in Portal. So the zone redundant configuration, this can be established for both new databases and existing databases. So when creating a new premium or business critical SQL database, when configuring it, all you have to do, so first take note that the estimated cost per month is $465. If you switch, all you have to do is click this button of yes, you want your database to be zone redundant. That's all you have to do to enable this, and your price stays the same. You click apply, and then you create your database, and that's it. That's all you had to do in order for it to be zone redundant. It's similarly easy to do for already existing databases. So in this example, we have a business critical database that already exists, and this is the estimated cost per month. And once you click yes in the configure blade in Portal, saying that you would like to make this database zone redundant, the cost doesn't change. You click apply, and that's all that needs to be done. It's and the configuration is automatically changing to be zone redundant. So as we saw in the demo, the zone redundant configuration is free, it's easy to configure, and it can be done for both existing and new premium and business critical databases that run on Gen 5 hardware. This uses synchronous replication to make the database resilient to a larger set of failures, including data center outages. With this feature enabled, even extreme cases, such as a meteor, can crash and destroy an entire data center, and your database will still be up and running in a different availability zone within the same region. It really is too bad that the dinosaurs didn't have a zone redundant configuration, isn't it? Now, while having a meteor crash into an entire data center seems like a dramatic case, there are actually many modern real-world examples where a zone redundant configuration would be able to save the day. One example of this is in 2011, Vodafone had a major downtime issue causing several 100,000 customers to lose voice, text, and internet access. And this created news that was sent all over the world where people heard about this major outage. And you might be asking, what caused this outage? So what happened was that a few thieves broke into one of the exchange centers and stole a bunch of computer equipment and network hardware. So what this animation is, just to give context, is this cartoon fox called Swiper is from a major children's cartoon in the US called Dora the Explorer. This character is known for stealing or swiping things. So while it's best for Vodafone and other companies to keep Swiper away from their databases so that none of the hardware and network hardware is stolen or removed or destroyed, even if someone like Swiper were to break in to your Azure data center, if you have the zone redundant configuration, this would save the day. Your database would still be up and running in a different AZ in the same region. Okay, didn't mean to go back there. Now, fun examples aside, what value does this zone redundancy actually bring in terms of availability for databases? Now, to understand this value, let's look at these SLAs that we previously discussed for uptime, specifically for Azure SQL, since this is the standard metric that's used for availability. Now, Azure SQL Database offers a baseline of 99.99% availability SLA across its service tiers, and it provides a higher SLA of 99.995% for business critical and premium databases that have the zone redundant configuration enabled. So by integrating with Azure Availability Zones, we were able to leverage the additional fault tolerance and isolation that AZs provide, which in turn allows us to offer this higher availability guarantee using the compute and storage redundancy that exists across AZs and the same self-healing operations that we see in all Azure SQL databases. Now, if you remember from the previous slide where we demystified the nines, that a SLA of 99.995% offers a 50% reduction in the maximum downtime from the baseline 99.99%. So in the time span of a year, a 99.99% SLA offers a maximum downtime of 52.56 minutes per year. And then for the SLA of 99.995%, this offers a maximum downtime of 26.28 minutes per year. So with these SLAs, we offer an industry-leading SLA that provides a lot of uptime for your databases in Azure SQL. Now this map, what this shows is all the regions where the zone redundant configuration is currently available for Azure SQL Premium and business critical databases and elastic pools. This slide also includes this link, which goes to our public documentation, where the most up-to-date information around what regions have availability zones enabled across different Azure services. So as this availability zone functionality is added to more and more regions, this will correspondingly be updated in this public documentation, which I'll share the slides out at the end of this presentation, so you have access to this and the other documents I've referenced as well. So now, after talking about how great zone redundancy is, and also previously discussing geo-replication, this leads to the common question of, what should I use when? It's advised that customers use the zone redundant configuration for all production databases. This synchronous replication is the only way to be protected against a zonal outage. Since this comes at no additional cost for premium business critical databases, this is really a good idea for any customer who utilizes premium and business critical service tiers, since you get all this additional availability at no additional cost and is easy to configure. Now for geo-replication, it's advised that customers use geo-replication for your more critical databases when it's necessary to avoid a region-level failure. This asynchronous replication allows for disaster recovery protection. While this does cost more, this is the only way to be protected against very large-scale disasters that would span across an entire Azure region. Now, one thing to note is that they can actually both be used together, as shown in this architecture, which is advised that customers do for Tier 1 apps. This combination allows the high availability with quick failover offered from zone redundancy, while also guaranteeing the ability for disaster recovery across a regional failure through geo-replication. Zone redundancy and geo-replication can be used together to make your database unstoppable. Now, I'm going to do a summary of what all we learned today. So, some key things that we learned through the presentation today. First, high availability is crucial. The world isn't perfect, and neither any hardware or software that exists. This is something we need to be ready to embrace by having systems that minimize the effects of a single failing component with as little downtime as possible. Next, high availability has improved significantly over the last 30 years. Looking back at 1989, where the closest thing we had to high availability were pretty infrequent backups taken on the same server, we now have so much more high availability offerings. We now have things such as synchronous and asynchronous replication options with several replicas. We have automated failovers, virtualization of connections to replicas, groupings of databases into single units of failure, speedier recovery systems, and built-in resiliency at even a global scale in the cloud. Next, Azure SQL offers the built-in industry-leading HA. So with Azure SQL, this maintenance and fault tolerance is built in to every single Azure SQL database, giving the customer a hands-off experience that is resilient to a large set of failures. We have a 99.99% uptime SLA across all our service tiers as a baseline, and an even higher 99.995% SLA when the zone redundant configuration is utilized for business critical and premium databases. Last, availability zones are the future of high availability. This synchronous replication guarantees no lag in committed transactions to secondaries, so there's always another replica readily available to fail over to with no data loss within the same region, even when a full data center goes down. Here is a list of resources from some of the concepts that I discussed today. So I only showed how to enable the zone redundant configuration in Portal, but here's resources on how to do this using CLI and PowerShell as well for both new and existing databases. So I want to take the time just to say thank you again, everyone, for attending. I know it's a Friday, and I know several of you are all across the world joining in on different time zones, so I really appreciate you taking the time to join this presentation. Specifically, I would like to thank Ben and Andy and everyone who put together this New Stars of Data conference. This has been a great learning opportunity for me. I also want to thank Bob Ward, who patiently took the time to walk through the history of high availability for Azure SQL and SQL Server with me, and had numerous discussions with me for me to learn more about how we've advanced over time. I'd like to thank Anna Hoffman, who has been an amazing and inspiring mentor for me throughout this presentation process. And lastly, I would like to thank my roommates who have always supported me and have allowed me to use the living room for this presentation. Great, thank you.
Emily, fantastic job, well done. So you can take a deep breath now and relax. We do have a handful of questions, so I'd like to send those over to you now. So the first question that we happen to have is, why would someone not choose zone redundancy if there is no extra cost involved?
Yeah, so I guess the one thing to take note of, so since your data is in a different availability zone, there is a chance of having a slightly worse latency with this replication since it's further away than within the same data center. However, the tests we've run, we've seen very minimal impact on performance and latency when using the zone redundant configuration. So while this is important to keep in mind, I still think personally it's best for if you're using a premium or business critical database to enable the zone redundant configuration, because like what was said in the question, it's free, it's easy to configure, and it really provides this additional resiliency.
All right, excellent. Next question. Are all of the 3 secondary replicas synchronously replicated to? Yes.
All 3 have synchronous replication, but that's for the business critical and premium tiers. So that's all within your same region. The geo replication that I talked about, where it spans to a different Azure region, that's asynchronous replication.
And that actually kind of goes along with the next question of, so the 3 availability zones, are they in the same Azure region or not?
Yes.
Yeah.
Yeah, the 3 availability zones are all within your same Azure region. So you also keep all of your replication within the same region. The real key thing about an availability zone is you have that separate power, network, and cooling. So that way if one AZ in your region goes down, the other availability zones in your region shouldn't be affected.
And also going along those lines, do auto failover groups only work within a single region?
So auto failover groups, I believe, are from multiple regions. I would have to double check on this just because this is more of a geo replication feature and I work more on the availability zone side of things. But since auto failover groups are an abstraction on top of geo replication, this should span across different regions. But I provide documentation about this in the resources, and I could check more on that later and get back to you to double check, just because the area I specifically work on is more the availability zone side of things.
So a different question. Going back to your high availability history, this is a 2-part question. First, okay. Someone here had noted that there didn't seem to be any history or improvements or changes in high availability in SQL Server 2017. And the second half of that is, in addition to ADR, were there any other HA-related features or improvements in SQL Server 2019?
Yeah, so this history that I provided for SQL Server and for Azure SQL was meant to be a high-level view of kind of like the releases that had really key changes in high availability, where we kind of had some game-changer technologies introduced. So that doesn't necessarily mean in 2017 there weren't any improvements. It just wasn't necessarily like a new technology that I wanted to call out for this overview of history. I'm actually not sure if what 2017 had in terms of high availability improvements, but a lot of additions in between the ones presented in this slide had different performance improvements between the different editions, or sometimes maybe like there'd be additional replicas, but I'm not sure specifically what happened in 2017. Now for 2019, there is ADR was introduced. There's more replicas in an always-on availability group. Those were 2 of kind of the key availability enhancements. I believe there's also a third. I think it was, I forget the name of it, but it's essentially that you, regardless of where your connection is, you can make sure that your connection routes to the primary. I'm forgetting the exact name of it, but it essentially allows your connections to be redirected to the primary regardless of what server you're actually configured with. Bob Ward, in his book, SQL Server 2019 Revealed, goes over this more in detail, and I can also look at the documentation behind this and send this over if you send me the contact info for this person.
All right. Let's see. One final question as of right now. Can I have merge replication with some specific database schemas and have always on with other servers between on-prem and Azure in North Central with Azure or with East 2?
Okay, so merge replication is only on-prem right now. There's not merge replication in Azure SQL. So my focus area is really more on Azure SQL and high availability in the cloud. So I don't really know all the intricacies involved in what can be done with merge replication, but this is something I can look into and get back to. Is it possible for you to send me the names of these people with the questions that I want to look into more so I can reach out to them specifically after this session?
So, I mean, I can copy and paste out the, their names, but it's just the names that they're supplying to us in the chat. So, for example, with one of the people who asked a question, it was just their first name, so I don't know. So, with the second one, Fernando, thank you. I got your email address, so I've copied and pasted that out. So, I will be able to send you that one. Yeah. And Arun, if you want to either directly DM me your email address, I don't know, you don't have to share it in the public chat if you don't want to. Then I'll take that down and then I can pass that on to Emily and then she can follow up with you directly.
Great. I can also share my Microsoft email address. I don't know how best to do that. I realized they aren't in the slides right now, but I can add them and share those to be publicly shared as well.
The easiest way, quick and dirty, is either edit one of the slides real fast and just type it into a text box, or pull up like Notepad or something and just type it in there if you want.
Yeah. Here, I can do that now. I'll put it on the title slide where I have my name. I'll just add my Microsoft
Easy enough
email address, so that way if people have specific questions after the session around high availability for Azure SQL, they can reach out to me to learn more.
Outstanding.
Okay, so I just added it, which it was on a different screen, but here's what it is. It's emlisa@microsoft.com.
All right, and I will also throw that into the chat as well.
Great, thank you.